Good afternoon, everyone. I would like to thank you all for joining us today in our continuing education series. Today our featured topic is Splicer and Cleaver maintenance. My name is Jessica Petchverhoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. So you've picked out your Fusion Splicer after much debate and research. And now there are some crucial things that you need to know in order to get the most out of your machine. Are you performing an arc test every time you use your splicer? Are your mirrors and cameras clean of dust and debris? If you've checked all the necessary points on the splicer and you still aren't getting good splices, it's time to take a look at your cleaver. Do you need to change the blade? Are the pads clean? Terry Power will be discussing all the factors that can affect your splicing performance. So at this time, I would like to introduce Terry Power. Terry is one of our senior instructors and an outside plant technician with over 25 years in managing networks. When Terry is finished, we'll be taking questions from the GoToWebinar chat box. Thank you again for joining us today, and at this time, I turn the presentation over to Terry.
And good afternoon, everyone. Again, this is Terry Power, and as Jessica said, I've been working in the field in telecommunications for about 25 years. I started in cable television in 1987 and grew into the fiber industry by 2005. I was working in Barbados, and 2007 took over as outside plant coordinator for Barbados, and have since been working in the fiber industry and full-time in fiber, and started here in 2009 running crews in the field, and then in 2011 came over full-time to the training division, and I'm now the senior instructor and primary traveling instructor at the fiber school here at fiberoptic.com. So that's just a little bit about me. Now let's get into the presentation. Today we're going to be talking about Fusion Splicer and Cleaver maintenance, and this is going to be basically the care and feeding and cleaning of your equipment that will keep you working day in and day out. And I want to remind everyone that you can go to the question box and ask your questions there, and we will take those questions at the end of the presentation. So, without further ado, we're going to talk about Fusion Splicer maintenance. We're going to talk about a few slides evaluating splices, looking at what is a good and what is a bad splice. We're going to talk about cleaning. We're going to talk about electrode replacement, and then arc calibration and arc test. Then we're going to talk about cleaver maintenance. We're going to talk primarily, well, we're going to look at some cleaves and look at what is a good cleave and a bad cleave. We're going to talk about cleaning and blade rotation and the blade height adjustment. So, splicer maintenance. First, let's just go ahead and get familiar with some of the parts and some of the areas we're going to be talking about. As you can see in the center, the fiber illumination LED, that's going to shine light up into the mirrors in the lid and then down into the cameras, and we'll show you those in a subsequent slide. We've got the motor-operated sleds or chucks, depending on what terminology you use, and that's where the fiber is going to be held firmly in place with the fiber alignment guides, and then the motor itself will move the chuck in a core alignment machine that's going to move up and down and then side to side, or left to right and up and down, and then when the fusion takes place, it will step the fibers together during the arc process. The magnetic latches are what hold the lid down and hold everything firmly in place. And as you can see, the area on the right, the retention pad, we're going to talk about that area specifically when we look at cleaning. And here you can see the cameras or microscope lenses that are used for viewing the fiber. Again, the light will shine from the LED up through the mirrors, be reflected down through the fiber and into the microscope lens, so that the fusion splicer can actually see the fiber and do whatever alignment it's going to do. And then, of course, the business end of the whole thing is the electrodes, the electrical arc between these two nails. Basically, they look like steel nails. The electrical arc between them reaches a couple of thousand degrees Celsius. It softens the glass, and then the motor-operated chucks will step together, and then it very quickly cools, and you have basically a welded piece of glass, a single piece of glass. And so when you're placing the fiber in the splicer, and we talked about this last month when we looked at actual fusion splicer types, but when you lay the fiber in there, if you look at the area between the blue pads, there where the line of the electrodes, and that area between the blue pads is the splice bed. And you want to have the end of your fiber, the cleaved end, about halfway between the end of your blue support, it's blue on this machine anyway, between the end of that support and the line of your electrodes. And then you close everything down and the machine will start working from there. You want it to look kind of like crosshairs on a scope. Okay, so splice evaluation. Some of the splices you might see might have some marks on them when you look at them. And your first indication or first inclination might be, oh my, this is bad. What's going wrong? You might have the white line or a blurred thin line, an offset in the cladding, a difference in the fiber diameters, or dirt on the fiber that you can see looking at X and Y is actually on the outside, not on the inside of the fusion itself. All of these are acceptable as long as the core is aligned and goes straight through. These faults, or what appear to be faults, these distortions will shoot just fine, and there will be no problem. Now, on the other hand, if you've got a black shadow or a thin black line, those are going to be issues that you're going to end up. You can try with those bottom two. You can try, if your fusion splicer has it, you can try to push the arc button again and give it an additional arc. Sometimes that will do it, sometimes it won't. If it doesn't do it after one more arc, you're pretty much going to have to break the splice and redo it. Now, a bulge or a bubble, there's no saving that. If you get a bulge or a bubble, you're just going to go ahead and break the splice and redo the work. So let's talk about some of these in one by one. So a bubble or inclusion, some of the causes might be a contaminated fiber interface. Might be, you might have touched it after you cleaved it. Because if you remember last week, or last month rather, we talked about you strip it, you clean it, you cleave it, and you put it straight in the machine. If you touch anything in between, you can get contamination, which can cause bubbles. It could be just simply a poor cleave, maybe a crack in the fiber interface. The fusion current could be too high. or your prefusion current or time could be too low. Now a bulge, auto feed too fast or incorrect current. I'm going to say that most of the time you get a bulge, that's because it stepped too fast or stepped too far as it brought the two ends together, and it pushed them too far in and basically smushed it outward. And that's going to cause the bulge. This is going to have to be broken and respliced. Now the thin black line is not fused all the way through. This is probably your fusion current is too low. Your prefusion time could be too short, but in this case that's going to certainly be an indication to me. My first thing is I would look at my current is too low, and I would immediately be running an arc calibration. We'll talk about that in a few minutes, but this is one of the times that you're going to be thinking about an arc calibration or arc test. Now a constriction like this could be contaminated electrodes, could be your current is too high or it burns for too long. Your current or the prefusion current could be too high. The feed rate or the gap too wide is probably going to be what I would look at first. And it might be that you didn't set them in far enough into the splice bed, and as it stepped together it thought it was close, but it wasn't close enough. And this looks like it's kind of almost touched and then stretched out. And the cores, of course, are not going to line up in this case, and you're going to have to break this and resplice it. Again, with any of these faults, including this one, match heads, or some people call them Q-tips. I always typically call them Q-tips. It's contaminated electrodes, fusion current is way too high, or the time is way too long. Again, the prefusion current way too long. Basically, this was just super hot. And either the auto feed didn't come together, it didn't step, or it was just so hot that it just blew it open. And in any case, with any of these situations that we've just demonstrated, arc calibration is going to be the answer to 90% of these issues. Okay, so cleaning the V-grooves and the bare fiber pads. You're going to want 99% isopropyl alcohol. You're going to want a V-groove cleaning brush, and you're going to want some tightly woven lint-free cotton swabs. Not Q-tips from the pharmacy, but those that are specifically designed to be tightly woven, debris-free, lint-free swabs designed specifically for working with optics. If you use Q-tips, you're going to leave strings everywhere, and it will make a mess. The V-grooves are the guides, as we saw in those previous photographs, that align the fibers and hold everything in place so the machine can do its job. If there's any debris, leftover coating, dust, shards of previous fibers, anything like that is going to cause the fiber to kick off to one side or up and not allow for the proper alignment. And of course, you're never going to get a good splice with that kind of situation going on. So if you close the lids and you look at the fibers, and one of them's kicked up to, off to one side or up and down, and it brings your left in, and then your right fiber is moving all over the place trying to find an alignment, that's usually an indication that something is misaligned, and it's probably because of a cleanliness issue. And one final note on this slide, and I see people do this all the time. They keep a can of canned air. Canned air is great for blowing dust out of computers, but it leaves a residue on optics. The propellant that blows that air out is going to cause you problems. It's going to leave a residue. It's either going to contaminate the electrodes. It's going to leave a film on your microscopes. And it's going to generally cause you to have a greatly diminished capabilities of your equipment. So you want to make sure and never, ever use canned air around the fusion splicer. All right, moving along. Now, the V-groove cleaning and the bare pads. Now, the bare fiber pads is that area we talked about in the beginning where I said you're going to want to make sure that that area is clean because it grips the fiber and holds it into the V-grooves. So you've got the V-grooves at the beginning, and then you've also got V-grooves. You're going to get a little highlighter and bring that in. Now, if you look, here's the bare pads we're talking about, here and here. We've got V-grooves on the ends, and we've got V-grooves at the inside near the electrodes. All of this needs to be clean so that we get a good seating and a good grip in here and a good placement of the fiber so that it can be precisely aligned. You want to moisten a V-groove brush with 99% isopropyl alcohol, and you want to sweep away from the electrodes. So you want to go from in here and sweep outward so that you don't push any debris down onto the lenses or down inside the machine. So that's how you get to the V-grooves. Now, the pressure pads, you can use a cotton swab with alcohol. Make sure you go back with another alcohol swab and dry it after the fact so that you don't leave any residue. And then lastly, if you look at that center picture, what it's actually showing is a piece of bare fiber that has been cleaned, stripped down and cleaned, and it's being used to run a bare fiber along the V-grooves to make absolutely sure that no dust has gotten down into the V-groove that the brush couldn't get to. And that's a trick that somebody showed me probably 10 years ago, and I've used that regularly, and that's what we tried to take a picture of there. Was to demonstrate that bare fiber being used to sweep the V-groove area. So cleaning the LED mirror cover. Now, as I said before, the LED is going to shine a light up into the mirror in the lid, reflect it back down through the fiber and into the microscope lens. This is going to be just like cleaning any other piece of glass. We're going to take an alcohol swab, 99% isopropyl alcohol. We're going to gently wipe the mirror surface. Generally, it's a good idea to do this in a swirling motion, starting in the center and swirling your way outward so that any debris is pushed toward the outside. Go back with a dry swab and wipe off any excess alcohol. You don't want to leave any air dry alcohol film on this mirror because it will diffuse and disturb the light and not give you as good illumination as you might get. And any diminishing in that illumination could diminish the ability of your fusion splicer to see the fibers and make a good precise fusion. Now, the microscope lenses, there are two of these. They're typically located right up under the electrodes. The procedure for cleaning these is no different than those mirrors. You take alcohol and a cotton swab, work in a circular motion swirling from the inside out, go back and dry it. In this case, we were able to get to the lenses without removing the electrodes, but the procedure that's going to take, we're going to talk about in the next slide, is going to talk about turning off the fusion splicer, opening the hood, and unplugging the fusion splicer. Okay, you want to make sure it is turned off, unplugged, any batteries are taken out. You do not want any chance that you're going to have alcohol, a Q-tip, and your hands working up in there, and that thing accidentally arc. It's going to be a bad day. So make sure that everything's turned off, batteries are pulled out, everything's unplugged, no chance that this has power. Then if you cannot get to the lenses with the cotton swab, as you see in this picture, you may have to remove the electrodes. We'll talk about the procedure for that in the next section. But then you want to find those lenses, work with a moistened cotton swab, work in a spiral motion out, sweeping any debris toward the edges, and then wipe it clean with a dry swab to avoid any spots. Then, of course, put your electrodes back in, and then we will have to do an arc calibration or similar after we put those back in. Now, replacing the electrodes. These are typically replaced after about 2,000 arcs. Now, different manufacturers are going to have different ideas, and they're going to give you different numbers. But typically, it's somewhere around 2,000 arcs. And then when you replace these, the procedure we're going to go through is going to mention resetting the arc count to 0 so that any conditioning arcs and arc calibration done on the new electrodes is counted as the count on the new ones, not on the old electrodes that we've already replaced. So the procedure here, we're going to use, again, we're going to make absolutely sure that the fusion splicer is turned off, unplugged, any batteries are removed. I do not want this thing to accidentally arc while my fingers are in there. I can imagine that would be an excruciating experience. And I burned a hole in my thumb when I was in the Air Force on a high voltage power supply, and I'm already very respectful of electricity inside pieces of equipment. So after you have made this safe, and no chance it's going to discharge, use your fingers to loosen the thumb screws and remove the electrode cover plates. Now the old electrodes will then be removed and discarded. Discard these, put some tape around them, put them back into the plastic case that you got the new ones in. Something, because these things tend to be pretty sharp, and as I commented earlier, they're very much like a stainless steel nail, and someone could get hurt. So, always being cautious, I try to make these things safe before I throw them away. Once you've placed the new ones in, well, we'll get to that in a minute, I guess, on the next slide. Make sure, as long as you've got the electrodes out, now's a good time to do another inspection and cleaning of your microscope lenses, since they will be so much more easily accessible. And avoid touching the metal with your skin. Skin oil on the electrodes will cause a residue, and then you arc and it burns onto the surface. And this will seriously degrade the ability of the arc to achieve the correct temperature, and you will end up wearing them out faster than 2,000 arcs or whatever the manufacturer's recommendation is. If you do touch them, You're going to clean them with alcohol and some gauze, and then put them back in. You can see from the illustrations here, the top one, we're loosening the thumb screw. The second picture shows the thumb screw removed and the cover plate is being slid toward the center of the fusion splicer. The bottom picture shows the cover plate completely removed. Now, to install the new ones, we're going to basically work in the opposite direction. Even if you haven't touched them, I think it's a good idea to go ahead and clean the electrodes with alcohol and gauze or Chem wipes or something, lint-free. Go ahead and give them a wipe down with alcohol. Make sure there's no skin oil from anybody else that might have handled them before you. Because, you know, I mean, the manufacturer could have packaged these, and while we know they're supposed to be wearing gloves, I'm not going to count on someone else doing it right when I can take 10 seconds and wipe this down with an alcohol swab. Now, holding the electrode by the plastic button, place the electrodes back into the retaining groove, and then slide the cover plate back into place. Some of them are going to have beveled edges that face toward the center. Some of them, like the images before, are going to have tabs and slots that will just slide back into place. Then put the retaining thumb screw back in. Do not over-tighten. If you over-tighten, you can either damage the cover, you can strip out the threads and it won't tighten, and then you got to send the whole machine off for service. Or if, in some cases, if you over-tighten, it will change the alignment of the electrode itself, and they won't be pointed directly at each other, and that will seriously degrade the ability to get a good arc current and good temperature. Now, after changing the electrodes, we're going to reset the arc count, and we're going to perform a conditioning arc and run arc calibration. Now, every manufacturer is going to have different ideas about what they call this. Sometimes it'll be conditioning arcs. Sometimes they'll just have you run an arc test after you do your replacement. Sometimes they'll call it arc calibration. Sometimes it's arc test. In all cases, what we're essentially doing is we're going to prep two fibers. We're going to put it in the machine, and we're going to run the arc test or arc calibration or conditioning arcs or whatever they call it. And what it's going to do is it's going to arc, but it's not going to step the fibers together. And it's going to essentially, as you see in this photograph here, it's going to do what I call blowing Q-tips. It's just going to arc and it's going to burn the fiber back. The machine is going to evaluate the image and determine if the arc is too strong or not strong enough, if the time is wrong, or anything like that, and it's going to adjust subtly the arc temperature, and then it's going to tell you to reload and do it again. And you could do this 4, 5, or 6 times depending on certain environmental changes, and we'll talk about that with the next slide. So don't get concerned if it tells you to do this 4, 5, 6 times. It makes very subtle adjustments, and when you see a screen that looks like this and says arc OK, that means it is dialed in for the proper arc conditions for the environment where you are. So when should I do an arc calibration or arc test? Well, of course, anytime you change your electrodes. That's at the bottom of the screen, but we're going to go ahead and say it at the top. Anytime you change the electrodes, even if you remove them to clean under them and then put them back, you'll want to run an arc calibration because you've removed and replaced the electrodes. Now, if you change fiber types, and I don't mean like standard single mode to NZDS, I'm talking about something like changing from multi-mode to single mode or vice versa. You want to go ahead and run a quick arc calibration, let it get the dialed in for that program, and just double check. It doesn't take that long. Changing splice location. Say you're working inside in a call center with air conditioning and humidity control, and it's the middle of summer, and then you go outside and it's 90 degrees with 90% humidity. These sorts of things are going to be those kind of extreme changes in temperature or humidity that would cause you to need to run an arc calibration to get everything dialed back in for the current ambient conditions. The initial splicing setup for the day. If you got poor performance, again, those drawings that we looked at the beginning of this section, any of those are indications that you might want to run the arc calibration, turn up the power, turn down the power, get it dialed in. And dirty or worn electrodes could be causing a degraded capabilities, and running an arc cal might get them to turn up a little bit more. But at that point, you also want to start looking at replacing the electrodes. So I think I actually covered a good bit of this slide already. So arc calibration, what is it? It's a built-in feature where it adjusts very subtle adjustments of the arc time and power to make sure that it's giving you just the right amount of power for the fiber that's being used. And again, don't be concerned if it tells you to do it 4, 5, or 6 times while it dials in. All right, so now we're going to move on to talking about cleaver maintenance. And remember, if you've got questions, you can put them in the question box. I see some of the questions have been coming through. And I will get to some of the questions at the end of the presentation, right after we talk about cleavers. So evaluating cleaves. The drawing on the right-hand side under the cleaver is obviously the correct way. That's what you want to see, a nice, beautiful, smooth, perpendicular cleave. What you see on the left side under the red X is wrong. It's bad. The one at the top is probably a dirty cleaver, very likely the outer pads. And we'll talk about which pads cause that kind of problem in a minute. The middle drawing has probably been impacted after it was cleaved. Sometimes the cleaver will do that on its own from being dull, but the dull cleaver blade that needs to be rotated or adjusted typically gives you that bottom drawing with a lip on it. The middle image is usually when you put one fiber into the fusion splicer, you go to set the second one in, and you bump into it. Or you tap it against the fiber holder as you're laying it in place. That will often cause that kind of ding on the corner, and that can also be caused by trying to clean it after you've cleaved it. Because remember, you strip the fiber, you clean the fiber, you cleave the fiber, it goes straight in the machine. We don't touch it after it's been cleaved. So areas to clean, the fiber grooves. Again, you can see in this drawing a bare fiber is being used to check and push any debris out of the small groove in the cleaver to make sure that it's lined up and precise before it's cleaved, because if it's curved off to one side, everything is rigid, and it gives you that precise cleave that we've come to expect from this type of equipment. Cleaning the anvil with a brush, that kind of acid or flux brush is, I think, one of the greatest, cheapest tools you can have in your kit. You can sweep out any debris, whether it's on the top pads or the anvil or the lower pads, even around the blade. I find that if I start getting a little bit of angle to my cleaves, first thing I'll do is sweep everything out with the flux brush and check to see if I've got any debris on my pads that's allowing the fiber to move when the cleaver blade touches it. And then, of course, cleaning the cleaver blade itself. This needs to be cleaned with a cotton swab and 99% isopropyl alcohol. And there was a question that was presented to me about whether or not a foam swab would be acceptable as long as it's a fairly firm. I've seen some of the foam swabs that were very floppy on the end, and they just bend over where it attaches to the stick. And if you're cleaning the mirrors and optics, that's not so bad. But if you're cleaning anything you want to put pressure on, you probably want to go ahead and get some kind of cotton swab that's going to have a little bit of resistance to it, the resistance of bending. Now, dust on the blade's edge can diminish performance. Use only 99% isopropyl alcohol, and pay particular attention to any shards on the top pads, particularly the one on the far right of that picture. Not the one the cotton swab is touching. The one in the middle is the anvil, but the one on the far right. And I've got a little bit of video here that maybe illustrates a tad bit better what I'm trying to say here.
So when I'm cleaving, I want to make especially sure that this pad and this pad are clean, because as the cleaver blade moves under, if these pads are not clean, fiber itself can move, and I'll get an angled cleave rather than a straight cleave.
Okay, so obviously I'm a big fan of keeping those pads clean. I have had a lot of issues with that in the field, and I've learned from painful experience. Keep that flux brush or acid brush, whatever you call it, nearby, and it helps keep debris out of the pads and lets the fiber be gripped correctly. Now, rotating the blade, after you start getting lips or cracks in the cleave, that's an indication that you've probably gone over your 1,000 cleaves or the blade is damaged. But in any case, it's going to need to be rotated. And the next couple of slides we're going to talk about typical procedures, but you want to get the instructions and the manufacturer's procedures for your specific cleaver and read those instructions. But we're going to look at a fairly typical type of cleaver here, and you'll be able to see some of the parts and some of the procedures. Now, I usually rotate 2 points, and we'll see that in just a minute. Now, we're going to loosen that set screw that's being pointed to in the picture. That's the retaining screw that holds the blade in place and holds it in position. So you want to loosen that, rotate the blade 2 positions. So go from 1 to 3 to 5 to 7, 9, 11, and then from 11 jump to 2, and then go all the way around to either 12 or 16, depending on the blade type you have. And that keeps you from getting over against the edge of the dull part. By rotating 2 positions, that just keeps you on a very fresh part of the cleaver blade. Do not touch the blade with your bare hands. Skin oil is not good for the blade, and the blade is not really a good thing to be raking against your skin. It's sharp. So in all cases, if you must handle the blade with your hands, get some of those lint-free cotton gloves. Do not rotate the blade with metallic tweezers. You're going to burr up the blade, you're going to get bad cleaves, and you're going to defeat the whole purpose here. Treat this blade with care. It is precise, and it is very sharp. So use a cotton swab to turn the blade. Usually you're going to rotate toward the front of the cleaver, and you can see the way the numbers run. So just rotate the blade from 1 to 3, etc., all the way around. Then pick up the even numbers. And then tighten the set screw. Do not over-tighten this. You can not only cause wear on the screw, but you could also warp the blade. And very obviously a warped blade is not going to give you a good cleave, and you've just thrown away a bunch of money. So do not over-tighten that screw. And then it's very simple. Just do a test cleave, look at it in the splicing machine, see how it looks, and that's going to give you your good cleaves again. Now, after the blade has been rotated through all 12 or all 16 of its positions, the blade height can be raised. Now, you can do this twice. So essentially, you can go all the way around every blade 3 times. Once at the lowest setting, then you get a whole nother rotation out of the middle setting, and then another set of rotation out of the 3rd setting. At that point, you're pretty much done, and it is time to look at the blade height adjustment. And then we're going to talk about actually replacing the blade. So the typical procedure here is you're going to find the screws. They're usually on the side beside the blade that hold everything in position. You're going to loosen those locking screws. Then you're going to look for the blade height adjustment screw. And it's a little hard to see in this picture, so again, I'm going to bring in a highlighter. And this is what you're looking for. It's going to be something like that. You're going to see the screw with some markings around it. And what you're going to do is you're going to turn that 1 position. Follow the manufacturer's recommendations. They're going to give you pretty good instructions and hopefully pretty good drawings that will show you where you're supposed to be. But once you do that first adjustment, then you lock everything back down. And again, do not over tighten any of these screws. You don't want to strip out the threads or the screws. And then you're ready to go through that set of rotations. Again, you can do this typically twice. Now, when do you replace the blade? Now, we've already talked about replacing it after 3 complete series of rotations. So once you've used all 3 blade heights, it's time to change out the blade and start over. If the blade is damaged, this could be warping from over-tightening. It could be mishandling, any burrs in the blade that have been caused by metallic tools that you were already told not to use around the blade. Any of that kind of damage will cause the entire blade to have to be replaced. So what's the procedure? Well, that set screw that we loosened to rotate the blade is the same screw that we're now going to completely remove to change out the blade. Now at this point, of course, it's safe to use tweezers because you're throwing it away anyway. So get the blade with tweezers. Again, don't use your hands. This thing, even after 3 cycles of rotations, this thing's still going to be sharp. It may not be sharp enough to give us the precision cleave we're looking for, but it's sharp enough to cut you, to open up the flesh, and that's not a good day. So be careful with this. Use the tweezers or gloves or something to protect yourself when you're removing it. Now, when you're putting the new one in, you want to use gloves so you're not putting skin oil on the blade. And again, you don't want to use metallic tweezers. If you've got nylon tweezers, that's probably a good plan, but metallic tweezers are right out. Don't damage the blade with tweezers, and make sure you're wearing gloves to protect your hands and the blade from skin oil. So hold it in place with the one position on top. Replace and tighten that set screw. And again, do not over tighten. You will warp the blade. Then look for your blade height adjustment. Set it to the lowest setting, and we're ready to go. At that point, I would still do a test cleave, look at it with the Fusion Splicer, but that's pretty much your maintenance on the Fusion Splicer, cleaning and care on the Splicer and the Cleaver. So before we go on to the questions, the sales department has asked me to pass along a little bit of information about a promotion. They've decided that all of our loyal viewers that have been coming into these webinars, they want to offer a 10% discount on a cleaning kit. This is one of the standard cleaning kits. It's got a tool bag. It's got some cleaning sticks and swabs that are appropriate for the type of cleaning we've been talking about, as well as connector cleaning. If you attended a couple of webinars ago when we were talking about connector cleaning. It's got some wipes. It's got some general kinds of cotton swabs, some gauze pads. There's some pre-soaked alcohol prep pads. Some squeaky clean, which is good for getting rid of icky pick in the outside plant cables. And there's a cartridge cleaner, a spare tape for that, and a couple of the quick clicks that we talked about for cleaning inside bulkheads. So, and anyone that has attended this webinar and uses the promotion code SMAINT when they contact the sales department will also get a free V-groove brush for cleaning out the V-grooves, and it's a kind of a gift for attending the webinars and for participating in this promotion. So you can call them at 877-529-9114 or email sales@fiberoptic.com. So there, I've done my part for the sales department and my buddies over there. Let's move on to questions. So I've got several questions here in the GoToWebinar in the question box here, and I can't read and talk at the same time, so I apologize if I while I'm reading the questions, because, you know, I'm old and I get addled. So let's see, how do I get the right gap between the electrodes after changing them? That's actually an excellent question. The procedure that each company is going to have is going to talk about that, but usually that button has a stop on it, and you're going to push all the way toward the center. In the drawings or the photographs we were using, you would push that in and slide it all the way toward the inside, and then put your cover plate back on, hold it in place with your thumb while you're tightening down the screw, and that will typically get you in the right place. They don't move around that much. It's pretty straightforward and easy to do. So, excellent question. Now, I got another question that came in through email that was just handed to me. And I don't know, this question might be in here again as well, but it's the question is, I've tried all of the stuff that you told me in this presentation, and I'm still getting bad splices. And the question is, where do you get service? Well, of course, you can send any machine back to the manufacturer, but you can also send it to fiberoptic.com. We've got a full bench test and service department here, and they do really good work. They maintain all of my training equipment, and I promise you the abuse that training equipment gets with brand new students, these guys do an amazing job of keeping the training stuff running. So you can always send stuff here, and we'll get you taken care of. Let's see. Excuse me. Okay. Now, clean after each use. Really? Okay, that's the question. What I meant by that, and perhaps I wasn't clear enough, and I have mea culpa. What I meant by that was after every day, after every overall usage. If I set up in the morning and I work all day, then I try to clean and dust everything, take an acid brush, sweep out all the debris and everything before I put everything away for the day. And sometimes during the day, if I start getting some bad cleaves particularly, I'll clean everything out. So not after every splice. I would not expect that. We'd spend more time cleaning than splicing, and I've been out there where I'm getting paid by the burn, and we're not stopping for cleaning every splice or cleaning after every splice. So let's see. Why shouldn't the blades be touched with the bare hands? The skin oil will penetrate the steel. Skin oil and steel have a long and nasty history together. One of my hobbies is to play with bladed objects, and I know from a lot of experience that if you touch with a bare finger the blade of the side of a blade, it's going to leave oil that will ultimately penetrate and induce rust, and obviously rust on your cleaver blade is going to seriously degrade the cleaves that you will get with it. So let's see. Someone here has had problems with splicing when taking a splicer from a warm temperature inside the vehicle or building to an outside where it's very cold. And the best way to transition the splicer and cleaver to extreme temperature changes. The only good answer to that is time. Take it out and let it cool off or let it warm up. You know, you might be going from inside where it's cold in a call center to outside where it's warm and humid, and you're going to get condensation on all of your optics. And you're just going to have to wait. Let that evaporate off. You can try wiping it, but it's probably going to condense right back onto the cold glass. The same thing works in the opposite direction. Going from a warm environment to a cold environment, you're going to want to let everything settle in and then run arc calibration, because that arc calibration is going to base the test arcs on the ambient environment. So if it's very cold outside, it's going to base the arc temperature, and it's going to blow those Q-tips, and it's going to look at the Q-tips and say, you know, I need to turn up the temperature on these arcs to get the shape I want. And it will keep adjusting, and you might do, as I said during the presentation, 4, 5, 6. I've gone from sea level to 1,000 feet above sea level in a day with the same splicing machine, and it took about 6 arc tests or arc calibration arcs to get it adjusted, because it does little bitty changes. It doesn't want to change it hard and fast. It wants to give a subtle change, and then it'll eventually settle in and say arc OK. So don't be surprised if in that environment it takes, you know, 6 arcs. So I hope that answered the question. Let's see. Okay. Okay, is the CT30 also adjustable, and does the cutting wheel need to be manually rotated? To the best of my knowledge, the answer to both of those questions is yes. I looked at procedures from Fuji and Sumitomo when putting this presentation together, and in both cases there were indications of blade height adjustment as well as manually rotating the blade after about every 1,000 cleaves. So not to say it too short, too short an answer, but yes. And do we service Corning splicers? I would have to verify that. I don't know. I haven't seen anything these guys couldn't work on. But I would definitely contact, I think I'd go ahead and email sales@fiberoptic.com and ask them. And also email training@fiberoptic.com. That's where, actually any questions that you have that you don't get answers to, or if you think of questions later, send them to training@fiberoptic.com, and I will make sure and get an answer to your question and put in the subject line something about the webinar so that it gets directed to me instead of to someone else in the training department. And that question about the Corning splicers and service, send that to training and to sales, and I will make sure we get an answer for you. And even splicing in a clean environment, my cleaver will occasionally break fiber, maybe 1 out of 20. This happens even after cleaning all the pads. What could be causing this? Dumb blind luck. I honestly, they're going to be bad cleaves. Something's going to move. If it's breaking the fiber instead of cleaving, I would look at the sharpness of the blade. I would look at when was the last time it was rotated. If it's giving you angled cuts, I would look at those pads as demonstrated in the video, and see if those pads, particularly the outer pads, are clean and free of debris. Sometimes it's very hard to see a little shard on that upper pad. They'll hide from you, and maybe even get around close to the edge and you don't even see it. But if it doesn't allow the two pads to close tightly, that fiber could move around just a little bit. And also check the cleanliness of the anvil area. If the anvil's not coming down and striking firm enough, it might break rather than give you the good crack propagated through from the anvil on the cleave. And let's see, I think that's it in there. If there's any more questions, here we go. Do we have archived training classes at the website? All of these webinars are archived, and they are available about a week after the presentation. So sometime around next Tuesday or Wednesday, you should be able to find this one online, and an email will be sent out to let you know that the on-demand version is available. But all of the recordings of all of our past webinars are available by going to www.fiberoptic.com/webinar. And there you can see all of the old webinars. And someone was asking about sharing the presentation with friends or with coworkers, and we would love it. Go ahead and get the video. The slideshow presentation does not get shared. We do not share that out. This is part of our training and our ongoing training programs. So these are copyrighted, and we do not share them in a way that you can just have the presentation. But you can always go and get the recordings of the entire webinar with the audio and everything that goes with it, and share that with your friends. Absolutely. We want to make sure that as many people as possible get this knowledge and the information that we're presenting, because it makes the whole industry better. So I hope that answers all of the questions. I want to thank everybody for attending and for sticking around during the question and answer session. If you have additional questions, please feel free to email us at training@fiberoptic.com, and we will find someone to answer the question for you. We know that your time is valuable, and you made some choices about how to spend your time today, and you chose to spend it with us, and we're honored. So thank you very much. Have a great week, and look for the on-demand recording of this in about a week. Take care, and we'll see you soon.